Good morning, everyone. Good morning, everyone. So let's start the session today. So welcome everyone for this C programming concept. So 1 second. So today's session we are going to discuss about arrays and its applications. I think till today you come to know what do you mean by C, what do you mean by variables, what are the usages, so how to use the variables and how to store the variables values like that. So now let's go for the new data structure, that is arrays and its applications. So let's move for the next one slide. So before going to the array concept, students, I want to tell you one situation. For example, you are in the second PU, students. Fine. Assume I want to enter the marks of yours. Okay, I want to 60 students are there in your class. So I need to enter the marks of all these 60 students. Okay. So if I want to write the C program for this particular concept, so here I have written one example for that. So I want to enter the marks of 3 students. Okay. So I have written the simple C program. So which consists of void main. Then since I need to store the values of 3 students, so I'm using the 3 variables M1, M2, M3. Then I'm telling the compiler that enter the marks of the 3 students. Then I'm reading the marks of all those 3 students. Then I am going to print the value of those 3 students. So in the right hand side, I given the input like M1 is 10, M2 is 20, M3 is 30, like that. Then the output of that will be displayed. Okay. So here, if you want to enter the 3 students marks, this is the case. But assume in your class you have around 40 or 60 or 100 students. Then at that particular time, I can't use 100 variables. For example, here I'm using M1, M2, M3 as the 3 variables for the 3 different inputs, okay, or for the 3 different students. But if I want to enter for 100 students, I need to take 100 different variables. Then it is meaningless and it is not the good style of writing the program. So here we face some issues. So then the length of the program will be more. Then the time which we consumed to modify and convert to give the values, give the input, everything will be more, and it will not look like the C programming thing. Okay, so to overcome this particular problem, we are using the new concept, that is the arrays. What is this array then? So arrays is nothing but, students, so it is a group of or the collection of same type of values stored in consecutive memory locations. That means if you want to store a values of 100 students, okay, it will be an integer value. Then complete 100 values we can store in a consecutive locations in our system. Or if you want to store the names of each 100 students, fine, then we can able to store all those things in an memory locations. So there is no need to give the different variables each time. By using an array, by using the one single array name, we can able to store the same type of data in our memory locations. So this array size may be anything. Okay, for our convenience, we can give the array size as 5, then we can give the array size as 10, or it may be 1000 or whatever it is. And at the same time, we can use the different types of data types. Okay, for example, you know the different types of data types, that is int, float, double, character, strings, like that. Fine. So by using all these data types, we can able to store the values. That means array is nothing but a collection of same type of values. If you ask, sir, is it possible to store the different types of values? No, it is not possible. Okay, so if you want to store a same type of values, then we can able to use the arrays. For example, second PU students. Okay, so I want to write the student names who belongs to the second PUC. So I can create the array of second PU. Then within that, I can use the data type character. Then I can enter all the student names in that particular array, which will be stored in memory locations. So that is the main use of arrays. No need to give the different variable for individuals. Okay, so once I give the array name with the size, within that name itself, I can able to store the required data of same type. Okay, so here I am given one example, int my array 5. That means within the array, my array, I am going to store 5 different values. Okay, so this is the way I am using the arrays. This is the main advantages of arrays. So we can able to store the same type of data without using multiple variables. Clear? So now I'm going to explain further. So here in the array, once I stored, so that value will be stored in the array with the single name. As I told in the example, my array. So the name of the array will be remain same. It will be my array only. It will like and single variable, my array. That's it. Then which is the name of the array, and we can going to use the index for each values. That is my array of 1, my array of 2, my array of 3, like that. So what is that index indicate? That index indicate the position of the value which will be stored in that particular array. That means, for example, if I say my array of 1, and if I give some value, that value will be go and stored in the location 1 in the my array list. Clear? So this is the main important thing. And what the subscript we are going to use in this particular array list, that will be a positive always. That means I need to write that subscript within the square bracket. That should be a positive number always. Clear? Fine. So that's why I given the structure of the array here. So for example, if I give my array of n, if I declare my array of n, then the structure, the memory location will be allotted like this. My array of 0, my array of 1, my array of 2, it will be going on till my array of n minus 1. Clear? So in the above figure, my array 0 represent the first element. And one thing you need to keep it in mind, students, once you start storing the values in the array, the subscript or the index value must and should start with 0. Okay. So if you give the value for the first location, you thought it will be stored in first, means the subscript for that particular location will be 0, because the array always start with the index 0, and it will be going on as it is 0, 1, 2, 3, like that. So I am given simple example also here. My array 1, 2, 3, 4, 5, or you may say my array 15, 20, 21, 22, like that. Okay, clear? Then let's go for the classification of array. So anyhow, you come to know what do you mean by array. So array is nothing but the place where we are going to store the same type of data, okay, in a continuous memory locations. So here the arrays can be classified into 2 things: single dimensional array, multi-dimensional array. But in sometimes we call it as single dimensional, 2-dimensional, and multi-dimensional. But 2-dimensional and multi-dimensional will same as the multi-dimensional itself. Okay, so 2-dimensional also will come under multi-dimensional array itself. Okay, so mainly we will classify the array into single dimensional array and multi-dimensional array. Clear? So now we have to follow some rules while using the arrays. So there is some conditions is there to use these arrays. What are those conditions? Means the array should be declared with some data type. That means some data type means either it should be an integer, or it should be a string, or it should be a character, or it should be a float, or whatever it is. But you need to indicate some data type. So that data type indicate that what type of data I am going to store in the array. Okay, for example, if I use int as a data type, then the values which will be stored in the array will be integer type. If I use string or otherwise the float as an data type, then the values which will be stored in the array will be of floating data type. That means the fractions 0.3 or 3.0 like that. Okay, then come to the point of second condition. All the array elements should be of same data type. That means, as I told already, array itself of same data type. That means once I declare the array as float, whatever the values which will be stored in the array should be a floating point data. Otherwise, the fractions. We can't mix it. I can't use the integer value. I can't use the floating point value. I can't use the rational value like that. Okay. If I declare it as float, it should be floating numbers. If I declare it as integer, it should be an integer number. Clear? Then in an array element are stored sequentially, that is in continuous memory locations. That means once I give the values will be stored as 0 position, first position, second position, fourth position, fifth position, like that. Okay, you can't skip any positions. Okay, it will be continuous, but you can add the value to the particular location. There is no doubt in that. For example, I want to add, once I declare the array, I want to add it for the fifth position, means I can add it for the fifth position. But once you declare the array, the values will be stored as from the 0 to n minus 1, like that. Only one element can be added or removed from the array at a time. You can't delete all the element at a time. You need to delete one by one. Okay. So as I told already, the subscript or the index of the first item will always 0. That means it will start from 0 itself. Then each data item is assessed using the name of the array, but with the different subscript or index. That means I want to know what is the element which will be stored in 10th position of an given array. For example, the array name is my array. So in the my array, I want to know what is the element will be stored in the 10th position. Then I can able to check out that by using my array within the square bracket by giving the index as 10. Then it will indicate what the value will be stored in that particular position. Okay, the index of the array is always an integer. You can't give the subscript or the index value as 1.0 or 2.0 like that. It should be always a number, integer number, that is a whole number, 1, 2, 3, like that. Clear? Then let's go for the declaration part. For example, anyhow, I am using the array. So if you want to do anything in the C program, first you need to declare that. Okay, for example, if I want to use the variable, for example, I want to use the variable a. So if you want to use the variable a, you need to declare that variable by using the data type. This is the common thing. So here also same thing. So if you want to use the array, you need to declare the array first. So what is that syntax for that? Okay, so declaration array for one dimensional I am talking now. Okay, so syntax to declare that particular array is given by data type, array name, and within the square bracket I need to give the size. What is the data type indicate? The data type represent what type of data or what type of data type you are using for the current array, and array name indicate what is the name you are given for that. For example, if I come to your college or if I come to your school, if I want to represent you or if I want to find out you, what I need to do, then I need to tell the section first, second PU, like that. Then I need to give some name for you. Then I need to declare what is the thing related to you people. Okay, so same way here. So the syntax for that will be the data type. That means what type of data it is, then array name of the array what you are given, and within the square bracket you need to represent the size. So here I am given an example, int numbers, within the square bracket I given 10. So what is that int indicate? Int indicate the data type. That means this array element will represent the integers. Then numbers will be nothing but the array name. And so name of the array given is numbers. Then what is the size of the array? So the size I want for this array will be 10. That means I can able to store 10 elements in that particular array. So this is the way we are going to declare the array elements. Clear? So data type, array name. What type of data I need? What is the name of the array given, and what will be the size? Clear? This is the syntax for declaring the array in one dimensional. Clear? So what about the two dimensional? I will explain later. Clear? Now let's continue this. For example, in another way I can declare the this one array as data type, array name. Anyhow, you know what do you mean by that size. Next, I can assign the value here itself. Okay, value 1, value 2, value 3, value n, like that. Okay, so data type, that indicate the data type thing, array name of the array, size, what is the size. Then what the value I'm going to store in this particular array, I can declare there itself. Okay, value 1, value 2, value 3, like that. Okay, for example, here I given float a of 5, then I given 0 0.1, 0 0.2, 0 0.3, 0 0.4, 0 0.5. Since it is a float, I given the fraction values. Okay, but in the previous slide, friends, here I given int numbers of 10. Okay, I am not specify the values. The values may be start from 10, 11, 12, 13, 14, like that up to 20. Or I can give the values as 100, 101, 102, 103, like that. So I don't know what value I'm going to store here. I simply know that it is of integer type, but I don't know the exact value here. But here in this particular one, I know the exact values because I declared there itself. Value 1, value 2, value 3. What will be my values? I declared directly here. Okay, so this is the another way of declaration. So you can do any one of this. Okay, if you know the exact values which you want to store in the array, you can clearly mention in the values. If you don't know what type of values you are going to store, then you simply type the data type and array name and what is the size you want. But size is must and should. Okay, so you need to know the size of the array which you needed further. Okay, so another example I given here is character of a of 5. So I know the values a, b, c, d, e, f. So here this is the thing I'm going to store it in the array. Okay, so here once I store these values, okay, once I given the values to the array like this, it will be stored like this. So array of 5, if I give the characters, a will be go to the a of 0, b will be go to a of 1, c will be go to a of 3, d will be go to a of 4, and e will be go to a of 5 locations. Similarly, if I give the integers, fine, then if I call the array of 5, then if I give 10, that will be go to the first location, 20 will go to the next location, 30, 40, 50, like that. It will be going on. Okay, so this is the way we are going to declare the thing. Fine. So now, anyhow, declaration part is over. So I declare the array. Now I need to initialize the array. So what is that mean? Declare means I am going to declare this value. This is the thing I needed. This is the thing I am going to use further. That's why I'm declaring this array in our program. That is the meaning of declaration. But what is the meaning of initialization? Initialization is nothing but I'm assigning the values for the required places for further processing. Okay, So that is the case. Initialization means assigning or providing the required value to a variable. Declaration means I am declaring that. That means I am going to use further in our program. That's why I'm declaring. I am giving the name for this particular thing now itself. So this is the difference between declaration and initialization. So once you want to use the array, you need to declare it first. Once you declare the array, then you need to initialize it. Initialize means you need to assign the values for that. Clear? Fine. So this initialization thing can be done in different ways. Okay. So what are those ways? Means first one, initialization all specified memory locations. That means, for example, I'm using the array a of 5. I'm given one example, int a of 5. Okay, so I reserved 5 memory locations for my program in the given array. So anyhow, 5 memory locations is there with me. So what the 5 memory location available for me, for all those memory locations, I am assigning the values. Okay, so since a array name is a, which is reserved for 5 memory locations, I am giving 5 values for this: 10, 20, 30, 40, 50, like that. So once I give the values like that, it will be stored like this. 10 will go to a of 0 position, 20 will go to a of 1 position, 30 will go to a of 2, 40 will be a of 3, 50 will be a of 4, like that. Then similarly, another example I given here, character of B4, where character represent the data type, B represent the name of the array, and 4 represent the memory locations which is reserved. Okay, so within that, since it is a character type, I am going to use the characters. And one more thing, students, you need to keep it in mind. If you want to use the characters, you need to represent that character within the single quotes. Otherwise, it is not be considered as a characters then. Okay, so if you want to use the characters in your array or wherever it is, you need to represent by the single quotes. So here I want to store the 4 characters V, V, C, E. Then I represent each thing with the single quote. So I consumed all the 4 memory locations, so which will be stored in your array like that. B0 position will be acquired by V, first V, then B1 position will be acquired by the second V, then B2 will be C, and B3 will be E position. Okay, so this is called as initialization to all the specified memory locations. So what the memory what the memory space you declared, for all those memory locations you are given the values. Okay, so whatever the reservation thing you are done, for all those reservation places you have filled all the items, all the elements. Okay, so this is called as initialization to all the specified memory locations. This is one type of initialization. Now let's go for the next one, partial array initialization. What do you mean by this partial array initialization? Assume I don't know the exact values, how many values I am having with me. Okay, so for example, I don't know the exact number of students which is present in that particular class. I need to enter the marks of all those students. So at that time, what I will do, I will think that there may be a 60 student in that particular class. So what I will do, I will call the array and I will reserve the space of 60 places. Okay, 60 memory locations. But I don't know the 60 members is there or not, but I consider the extra values because I don't want to get disturbed in the middle. So I am consumed more number of places earlier itself. Okay, so I reserved some extra places. Fine. After reserving extra places, I come to know that there is only 40 students. Okay, so then I will use all those 40 places. What about the remaining 20 places? That remaining 20 places will not be having anything. It will be stored simply by using zeros. Okay, no need to enter 0 also. The system will itself give the values as default value as 0 for all those locations. Okay, Clear? So this one is called as the partial away initialization. That means I declared some, I reserved some memory locations, but I am not using all those memory locations. I am using only limited of that. Remaining will be left empty, which will be consumed as zero or by using the default values. Okay. So for example, here int a of 5 I given. Okay, I said int a of 5 and I given the values 10 and 20 itself. So I reserved for 5 memory locations, but I am using only two values, that is 10 and 20. Okay, so remaining position will be zeros. So if you check it out there, 10 will go to the a of 0 position, 20 will go to the a of first position, but a of 2, a of 3, a of 4 will be 0. So you're not taken that 0. The system, the compiler itself will place the 0 to that particular places. That is default value. We call it as the default values. So this is called as partial away initialization. Okay, that means I used the away partially. I'm not consumed the complete away. I'm using only the partial away. Clear? So this is the one thing. Then come to the point of next one, initialization without size. That means I don't know what is the size. Okay, so I don't know what is the number of students are there in that. I can't imagine also. Sometimes, for example, in the crowd, if someone asks what is the size, what is the, how many members are there in that particular crowd, means I can't give the justification. So at that particular moment, I can't simply say the random value also. Okay, so same situation here. So sometimes what happen means I don't know the exact value of elements which is present, but I want to store all those elements to the away. At that time, I will go for the initialization like this. So initialization without size. I am not mentioning any size here. I simply call the array without the index value or the subscript size value. Okay. So int a of only the brackets I will use. I'm not mentioning any size within that. Okay. Once I use that, I will simply give the values as 10, 20, 30 like that. Then the compiler will itself come to know the size of that particular array and it will store all those values to that particular positions. Okay. So in this particular example, initialization without size, I am using int a of bracket. That's it. I am not mentioning any size because I don't know the size of the array. I am giving the values. That's it. So I given the values as 10, 20, 30. The compiler itself will consider the size and it will store all the values to that particular location. So 10 will go to a of 0, 20 will go to a of 1, 30 will go to a of 2. So this is another way of initialization, students. So here, the first initialization is initialization or specified memory location. Second one is the partial away initialization. Third one is initialization without size. And next one is away initialization with the string. So how to use the string and how to store the string in the array. So if you want to store the string in the array, so you need to use the data type as character, then B of, that is array name is B and size I don't know. I simply, you can give the size if you know the exact length. If you don't know, so you simply call the square brackets. So here I given the computer. Computer means it is 1, 2, 3, 4, 5, 6, 7, 8. 8 characters is there totally. But sometimes I don't know what is the length of the string. So at that time, I will simply leave the bracket. If you know the exact size, you can give the size of the array also. Okay. But in the case of the string, students, you need to keep it in mind what is the length of the string you're having plus one extra position you need to declare. You need to initialize. Okay. For example, here I am given the string name as computer. Totally it is 8 character. Okay. But I need to declare it as 9. because the last position is always a slash. Okay, so that is null pointer. We call it as null pointer. We need to reserve one place for that. Keep it in mind. So while initialization of string, you need to keep it in mind, students. What is the length of the string you are having? Plus 1 you need to declare. Okay. So for example, if your length of the string is 8, then the array size you must declare as 9. If your length of the string is 100, then you need to declare the array size of 100 plus 1. Why that plus 1 means? The last one is the null pointer. This is only in the case of string, student. Keep it in mind. So here I given the character b of, I don't know the size, so I simply given the open the bracket and close the bracket. Then within that I given the values as computer, and keep it in mind, since it is a string, I need to represent entire thing within a double quotes. So if I want to place the single character, I need to represent it within the single quote. If I want to represent the string, I need to represent by using the double quote. Okay. So here, once I declare the array like this, the values will be stored in the array memory locations as given below. So C will go for the B0 position, 1 will go to the B1 position, M1 will go to the B2 position, and it will be going on like that. And finally, in the B8 position, that is after the letter R, I need to place the /0. That means the null pointer. Okay, which will be stored in the B8 position. Clear? So 8 plus 1. The array will start with 0 and it will go till 8. That is 8 plus 1 memory I need to reserve. So these are the 4 different types of initializations are there with the array, students. Clear? Then one main important thing you need to remember, students. For example, I know the exact value. Okay. For example, I am having the 4 values. So you can declare the array for 4 itself, or you can declare the array for 5, or you can declare the array for 6. But the size of the array should not be less than the values what we are having. Okay. If it is like that, then the compiler will give the error message. Okay. Simple example I given here. I declared the data type as int, and I call the array name as student, and I declare the size as 3. But how many values I am having in the within the brackets? Check it out. 4 values: 22, 23, 21, 24. Okay, that is 4 values I am having, but I declare the size as only 3. Okay, at that time it will throw an error because the size of the array is less what the values you are having already. Okay, so that is the error message it will print. So this is not possible in the C. Fine. So next, let's go for the types of the array. So the types of the array, as I told already, there are 2 types actually. Mainly we classified the array into 2, that is one-dimensional array, and another one is multi-dimensional array. But in some textbook they will say that one-dimensional, two-dimensional, and multi-dimensional. But two-dimensional will itself come in the multi-dimensional. Okay, 2 is also a multi-dimensional. Okay, whatever the way you want, you can see maybe one-dimensional or multi-dimensional, or you can say in another way one-dimensional, two-dimensional, and multi-dimensional. Okay, so what is the difference here means in the one-dimensional array we are having only one subscript or only one index value. Okay, but come to the point of two-dimensional or multi-dimensional, the subscript or the index value will be more. Okay, for example, in the given example, my first one, my array of 2 I given, so which represent one-dimensional array because there is only one subscript value is there. Okay, then come to the point of my array 2 of 2, that represent the two-dimensional array because there are 2 subscript value is there. Similarly, come to the point of last one, I'm using more than 2 or more than 1, which will be 3, 4, 5 or whatever it is, which represent three-dimensional or multi-dimensional like that. Okay, clear? So this is the types of the arrays we having. Okay, so based on the subscript, we will decide what type of array it is. If it is having only one subscript, then we will say it is one dimensional. If you are having two subscript, it will be two dimensional. It will be, if you are having n dimensional, n subscript, then it will be n dimensional. Clear? Then each pair of subscript contain the numbers elements correspond to specific dimension. For example, if I am using 2, then one is for example, if I use my array of 2, then I will say 2 is for row, 2 is for column, like that. Clear? So this is the types of the array I'm having. So now let's go for the simple example, students. Okay, so I'm written two program here. The two program I want to show the differences without using the array concept and with using the array concept. Okay, so here in the left hand side, I'm saying that I want to declare the value of a. Okay, so how to, for example, I need to take the variable a. Okay, I need to assign some value for that, then I need to print that. Okay, so here I'm using the variable a. So if I use the variable a, I'm using only one variable, that is a, so I can able to store only 10. That means only one value. If I want to store multiple value, is it possible? No, it is not possible. Okay, so because I'm not using any array concept here. Okay, so simple thing, hash include stdio.h, I'm using the void main, then I'm declaring the variable a with the value 10. So then I will say that print that value. So what will be the output you will get at this time? The value of a is 10. Okay, so what the value which will be stored in a, that will be printed. But come to the point of array concept, students. Here I'm using the same a, but I'm not declaring it as a variable. I'm declaring that a as an array here. So a of 3. So here I declared int a, that is equal to 10. So there a is act as a variable, but here int a of 3 is equal to 10, 20, 30. There it act as an array. Okay, so within the array I need to assign the values. Okay, so keep it in mind, students, since I need to assess the value for the array a, so I need to repeat the array 3 times. That means I need to store the values for first position, I need to store the values for the second position, I need to store the values for the third position. So for that particular purpose, I'm using the for loop here. Wherever the array concept will come, the for loop must turn should. To assign the values also for loop needed. To print the values also the for loop will be needed. Okay, clear? If it is an one-dimensional array, one loop is enough. If it is multi-dimensional array, that much of loop is needed. Okay, for example, two-dimensional means I need to use two for loop. If I three-dimensional means like that, it will be varying. Okay, clear? I will give the example for that one also. Okay, so here, so since I need to store the values 10, 20 and 30, so I am using the for loop here. For loop I is equal to 0, that is the initial value, I less than 3, that is the final condition, and I plus plus, that is increment. Okay, clear? Then print percentage d a of I. So once I say print, whatever the values which is stored in the array, that will be printed as 10, 20, 30. So in this particular program, students, I'm using the array concept. Since I'm using the array concept, I have declared only single array. So within that array, I'm declaring 3 values. Okay, but in the without array concept, I'm using only one variable. There, I'm using only one value. Clear? Fine. So that is the thing. So by only one variable and one value, but here one single array, but within that array I'm using three values. Okay, this is the major usage in the array. Then let's go for another example. So as I told, you can give the values if you know exactly what you want to store it in array. Okay, that part you can do it at the time of declaration itself. Okay, so while you are going to declare the array, so there itself you can give the values which you are going to store in the array. But sometimes I don't know what the values I needed to store. At that time, I will declare only the array, but at the time of running the program, I will assign the values for that. So I need to show the difference between these two. So if I want to declare the array and I need to store the values there itself at the declaration time itself, what is the way of writing the program? And another thing is, at the time of running the program, if I want to give the values, what will be the way I need to give? Okay, so this is the thing. Let's go for that. So here in the left hand side, I am using the array and I know what the exact value I am going to store at that particular array. Therefore, while declaring the array itself, I given the values. For example, int ARR, I given the array name as ARR and I given the size of the array is 5. Since I given the value of array is size is 5, I am going to store 5 values: 10, 20, 30, 40, 50. This is the 5 values I am going to store it in that particular array name ARR. Okay, since I know the values I'm going to store it in array, I'm declaring the array and I'm initializing there itself. Okay, that's why in the comment statement I given array declaration and initialization. Okay, so later on if I print that array, I'm going to get the output as 10, 20, 30, 40, 50 like that, because this is the value which is already stored in the array. So if I print, so I will get the same values. Come to the point of right hand side, here I declare the array, that's it. Enter the size of the array. So what is the size you want? You declare at that moment. Dynamically you can declare. If you want the size of the array is 3, you declare it for 3 at that moment. Next time if you want to increase the size for 5, you increase the size to 5. If you want to decrement the size, you decrement the size. So everything will be done at the time of running the program. Okay, so here in the right hand side, enter the size of the array I given. Then I am reading that n value. What is the size I want for this particular array at this particular moment? Okay, if I give the n value as 5, then that particular for loop which I have written in the next line will be run 5 number of times. Okay, and I am going to read 5 different values. So see the scanf %d ampersand ARR of I given. That means I don't know what the values I'm going to store. So at the time of running the program, I will give the values. Okay, dynamically I will give the values. That is the meaning. So once I give the values to the array, it will be stored in array. Then once again, if I want to print that array, so I can print by using the printf statement. Okay, but as I told already, students, both for the assigning the values and for printing the values, the for loop is must and should. Okay, clear? So enter the size of the array, the output will look like this. Enter the size of the array. If you give array size is 5, then you can enter the 5 values. Next time if you run, if you give the size of the array is 3, you can enter 3 elements. Next time if you run, if you give the array element as 100, so you can enter 100 elements like that. Clear? So this is the difference. How to declare the array and how to initialize the array and how to give the input at the time of declaration itself and at the time of running the program. Okay, so this is the thing. Now another simple example I given, so same as the previous one. So I given the I have here one more thing is I don't know what is the value I am going to store. Okay, so what is the total number of values I'm having? I don't know. So here I simply call the array of 25. So int ARR of 25, but I'm not using all those 25 values. I'm using only 5 or 4 or whatever it is. Okay, that's why enter. I reserved the space there. I reserved the space for 25 memory locations, but I'm each and every time when I call the program, I will ask enter the size of the array, but I want to enter the n value within 25 itself. I can't give 26, I can't give 30, I can't give 100, because you have reserved the memory location is only 25. So here the size of the array is restricted, but within the 25 you can give any values. Okay, you can use all the 25 memory locations, or you can use only 5 memory locations, or you can use only the one memory locations, whatever it is, that's your wish. Okay, so remaining thing is same. So if you want to read the values, you need to go for the scanf statement. If you want to print the values, you need to go for the printf statement. For both scanf and printf, you need the for loop. Okay, so output will be look like this. Even though I reserved the 25 memory locations, I'm using only 5 array locations in that. Within that 5 memory locations, I am given 10, 20, 30, 40, 50. So once I given these values to the array, and if I print, all those values will be get printed. So what about the other values? What about the other positions? The other position will be assigned as the default values, but you won't get it as the output. Okay, so the value will be stored will be default values, but it will not be printed. Okay, clear? Then come to the point of two-dimensional. Till now I am learning the one-dimensional array. So here I am going to discuss about the two-dimensional array. As I said already, two-dimensional array means here I am going to use two index. Okay, as subscript. Okay, so one subscript will represent the row and another subscript will represent the column. Okay, so here the remaining thing will be same as the single dimensional array, that is data type, array name, everything must and should be given, but I am using two different subscript. That means first subscript will always represent the row size, the second subscript will always represent the column size. So I given the example here. Example, int a of 4, 3. That means int is a data type, a is a array name, and 4 represent the size of the row, and 3 represent the size of the column. So you will get an array of 4 cross 3. It look like a matrix. Okay, clear? So this is about the two-dimensional array. Clear? Fine. So I just given an example here. So int a of 3 comma 4. Okay, so I am given the example as, and the syntax is same, data type, array name, row size, column size. Same thing what I mentioned in the previous slide, same thing I mentioned here. And two-dimensional array requires two subscript values always. Two-dimensional array stores the values in the form of matrix, obviously, because it represents the row to one subscript for row, another subscript for column. Then obviously it will look like a matrix. Then one subscript will represent the row and another subscript will represent the column. So I given the example here, int a of 3 comma that is 3 of 4. Okay, that indicate 3 row and 4 column. So you can check the graph here. You check the figure here. So it containing 3 rows: row 0, row 1, row 2, and it contain 4 columns: column 0, column 1, column 2, column 3. So here also keep in mind, friends, everything will start with 0 itself. It will never start with 1. Even though if you initialize the array as a of 3 comma 4, that means 4 column is there, means column will also start with 0, row will also start with 0 itself. So and it look like this: a of 0, 0, a of 0, 1, a of 0, 2, a of 0, 3, then a of 1, 0, a of 1, 1, like that. It will be going on. Then in the two-dimensional array, if I declare it as a of 2, 3 comma 4, I want to explain simply for your reference. I have done a table here. So number of subscript variable required is 2. For two-dimensional array, the number of subscript variable required is 2. And if I declaration is a of 3 comma 4, that indicate number of rows is 3, number of column is 4, number of cells is 12. In the previous slide, you check it out here, how many cells is there? A of 0, 0, A of 0, 1, A of 0, 2, A of 0, 3, like that. There are totally 12 cells is there. So 12 cells, and number of loop required to iterate is, since it's a two-dimensional array, I need two for loop. Even though for read the data, and even though if I want to print the data, I must and should need two for loop. Okay. Then how to read the data by using the two-dimensional array element. Okay, so if you, as I told in the previous slide itself, if you want to read the data or if you want to print the values which is present in the array, or if you want to store the values to the array, so must and should you need to use two for loop. Okay, one is for row and another one is for column. That's why here I'm using two for loop for reading the array element and two for loop for printing the array element. So for I is equal to 0, I less than row. What is the row size you are given? Till that it will go I plus plus. Then for j is equal to 0, j less than column. That means how many columns you are given? Till that it will run j plus plus. Scanf, you know what is the use of scanf, and a of ij. So I'm reading it. Same thing will be repeated in the printing. So it will print all the values, but by the use of two for loop. Clear? Then writing the C program to read and print the element of a matrix. So I'm given simple example here for you people to understand how to write the C program by using two-dimensional array. Okay. Here I'm using stdio.h and I'm using void main. Then int a of 10 comma 10. So I given row size as 10 and column size is 10. Okay, and I need to declare I and j, which will be used for loop. Don't think that I need to use I and j only for loop. You can use m and n, or you can use a, b, or whatever it is. That's your wish. Okay, I'm using I and j. That's why I'm declaring it. Then I want to read the two-dimensional array. Then I use the for loop for I is equal to 0, I less than, what is the row size I given? 10, I plus plus. Then for j is equal to 0, what is the column size I given? 10. So j less than 10, j plus plus. Then I am using scanf ampersand a of ij. So if I use this, I can able to read 10 elements into my array. Okay. So if you want to write two-dimensional, if you want to print, so same thing I used, but I without ampersand because I am printing that array. Okay. So here, example of multiplication of matrix. I think this program you are very familiar. Okay, so I think you have done so many number of times this multiplication of the matrix. So I have taken that particular thing itself. You know how to do the matrix multiplication thing. Okay, so same thing I want to represent by using the C program. I am having an array A matrix and B matrix, and I need to multiply these two matrices and I need to store the result in the C matrix. Okay, so how to do that? So here I'm declaring the A matrix as A of 5 comma 5. So row size is 5 and column size is 5. Same way I'm declaring the B matrix of 5 comma 5 and I declaring C matrix as 5 comma 5, which is a resultant matrix. And you need to keep it in mind, students, while doing the multiplication thing, what is the conditions and all you need to remember. Okay, so then I'm using the variables m, n, p, q, i, j, k, everything. Then enter the size of the first matrix. So what is the size you want? You need to mention. Okay, it may be 2 cross 2, it may be 3 cross 3, or it may be 2 cross 3, or whatever it is. Okay, so you need to enter the first matrix size will be readed in the statement. Then enter the size of the second matrix. Okay, you need to read the second matrix size also. And one thing you need to keep it in mind, students, first matrix column and second matrix row must and should same. Okay, 2 cross 3 and 3 cross 4. If the first matrix column and second matrix row, if it is same, enter the element of the first matrix. If that condition will not holds good, I can't do the matrix multiplication. That basic condition, you know. That's why I mentioned here that basic condition, if n is equal to p. Okay, single equals represent assigning and double equals represent equals. Okay. Here I'm checking that condition, is it n is equal to p. If that condition is true, then enter the elements of the first matrix. So I'm reading the first matrix. So you know how to read the matrix. Then enter the element of the second matrix. So you need to read the second matrix once again. The A matrix will be read here, and the second B matrix will be read. After A and B matrix, the reading the matrix elements is over. Now I will come to the main part. There, for I is equal to 0, I less than m, I plus plus. For j is equal to 0, j less than q, j plus plus. Initially, C of ij is equal to 0. That means the resultant matrix is 0. Nothing is there in the resultant matrix. If you are not used that particular statement, some garbage value may be there in the resultant. So what the answer you will get, that answer will get combined with that garbage value, then it will give the wrong answer. That's why I will declare C of ij is equal to 0. I will initialize C of ij is equal to 0 in the beginning itself. Then I will do the multiplication part. So what is that multiplication part I have given? C of ij is equal to C of ij plus A of ik into B of kj. Okay, so this is product of the true matrix that will be stored in the C of j. Finally, it will print that particular matrix. Okay, if this n equal to condition fails, n equal to p condition fails, it will come out of the program and it will print multiplication is not possible. Okay, so this is the way the program will work. And this is the end of my session. I think in this particular part, you come to know what do you mean by array, what is the usage of the array, how to declare the array, and how to run the array, then how to use the this one single dimensional array, and how to use the multi-dimensional arrays. Okay, thank you everyone. Thank you for coming online and listening my sessions. Thank you so much. And the PPT and everything will be shared in the YouTube if you want. Clear? Thank you everyone. And the next session will start after 5 minutes break. Thank you. Call. Hello. Okay.
Hello, good morning everyone. Myself Naveen Kumar, Assistant Professor, IS&E. So today I'll be talking about functions and what are all these functions, what kind of, what are all the different types of functions we have. Why do we need function in C basically? So as you can see in the slide, there are different modules which I have taken, or maybe you can see the structure like M1, M2, M3, M4 and M5. So there is a structure in this particular PPD you can see. The same way when you are writing a C program, you need to arrange your program in such a way that it should be like understandable and then the modular things. Like, so the modules, what you are going to write will be there in a particular structure. So if I take one module, I can divide that particular module into several sub modules, and I can make a structure out of it. So whenever I write a C program also, say it is some 1,000 lines you have written. So these 1,000 lines, it will be very hard for somebody to actually see what exactly is there in the program. And that time, what we need to do is we need to separate or divide that particular 1,000 lines of code into a specific a task kind of thing. There your function will come into existence. So to start with, so what exactly is a function? A function definition, like a function is a program segment that carry out a specific or a well-defined task. So in mathematics, you can see there will be some input. After that, you'll process something and you are going to get some output. In the program also, when you give your variables as an input, after that you will see something outside on the screen. So that is the output what you get. In between, what are all the things happening, that is between your keyboard and the compiler, you would be not knowing what exactly is that. So a function is a function can, which does a specific or a well-defined task. If I take an example of mathematics, like I want to draw a straight line on a surface, right? So or maybe on a space which is having x and y coordinates kind of thing. So on that time, what I will do, I'll take the formula, that is y is equal to mx plus c, right? Where c is some constant which I have, and then m is the one which is the gradient, right? So x and y would be my unknown values, or maybe the coordinates which I am going to plot. So that is how you are going to tell a specific task, right? In order to get to know whether it is a straight line or not. So here also in the programs, we'll give some input to a particular set of instructions. So that instructions would do something, and then it will give you the output. So that is the basic or a fundamental definition of your function. Next, we'll see what are all the different types of functions we have in the C. So there are two different types of functions. One is the library function, or we call it as a predefined function. The other one is user-defined functions. What exactly is these library functions? Library functions are the one which are predefined. So from the previous sessions, you have come to know that every program would start with hash include stdio.h, hash include conio, that is conio.h. So all these are header files, right? So these are all the things which are like predefined by the C compiler or maybe the C language, where you don't know what exactly the what is the implementation, what you have inside that particular function. The code and all, it is very abstract. You people will be not able to see what exactly how your compiler is reading the data which you are giving from the keyboard and making it to appear on the screen. So everything is abstract, right? You'll just type on the keyboard and then you will see that on the screen. So that is some of the standard input output. So that is the library function. And then user defined function. User can also define the function, right? So that is the basic idea. I want to do something with the computation. I want to calculate something. I want to find the area of a triangle. I want to find the area of a rectangle, or I just need to find out how much air is present inside a particular room. So I'll consider the area of that particular room, and then so many other aspects. Say for example, if I want to write that kind of function, or I need to find out what is the temperature or the room temperature of this particular room, then I should write a function of my own. So that is called as user defined function. So let's see some of the examples for library functions. The library functions here, the or maybe predefined function, you can see a printf and a scanf and the square root. So these are all the example. So in order to use this printf and scanf, you need to include a header file called stdio.h, that is standard input output.header file. Header file is nothing but a package which contains so many other different functions. As you can see, a printf and a scanf, they do have a different kinds of prototype, or which takes the arguments, right? So in this program, you can see I have included 3 header files, right? If I am performing some of the calculations, say for example, I want to calculate what is the square root of a number. On that time, I can include a math.h, which actually define. So in order to get the square root of x, say for example, I have given x value is equal to some 5. After that, I should pass that particular x value to the function, that is square root, and I will get a answer as 25, right? The same way here. So as you can see in the program, it is void main int total. I'm just like, this program is just giving me the output of addition of 2 numbers. What exactly is that? Here what you need to concentrate is the printf and the scanf. So these two are predefined function, right? In the printf, you can see after writing printf, there is an open bracket, and then followed by a string which you are passing will be there in the 2 double quotes, right? So that double quotes is nothing but the argument, right? A string argument, or maybe it is a character buffer, we call it as. So if you go in depth, like what exactly is the printf, why we need to use the printf only, or maybe scanf only, then you will get to know what exactly the arguments this printf and scanf would be taking. In the next line, you can see a scanf which is taking 2 or 3 arguments over there. First a string, followed by a variable, and then the address of the second variable. So ampersand will give you the address of a particular variable. After that, I am calculating what is the total of this a plus b, and then I am trying to print that particular a plus b. So that is the example of predefined function. When it comes to user defined function, so how an user can define a function for his for his purpose. He want to calculate this same addition. Instead of writing the program in the form of lines, what I will do, I will divide my program into some modules, different modules. Say I want to perform a addition, I want to perform a subtraction, or maybe a multiplication, or maybe division. So I want to write a simple program in order to a simple program of a calculator. So on that time, what I can do, I can separate all these different functionality. Addition is different from subtraction. Subtraction is different from the division. So I can, what I can do, I can separate all these things. So one separation is here. So you can see there is a void function that is main. So main is the first function which actually where your control enters. When you start compiling your program from main function, it is going to take the control from the main function. Your program start executes, and then it will come to add. So I have given add, and then the control will go to the void add. After that, you can see the same thing. It is reading. I'm initializing 3 variables, that is total a and b. So these 3 variables are integer variables. I'm telling that enter the values for this a and b. After that, I'm reading the content, that is the scanf. I'm reading the contents from the keyboard, that is ampersand a and ampersand b. I'm performing the operation, that is total is equal to a plus b, and then I'm printing that particular things. So this is my user defined function. When it comes to what are all the elements are there in the user defined function, as you saw from the previous slide, that is like a predefined function, that was my scanf, right? A scanf did not had any kind of type, or maybe a name, or maybe the arguments are going, you have to pass the arguments. It was there, but it did not had any kind of type, or maybe the name of that particular function, right? So whenever a user is defining a function, the user has to tell this is my function definition. After that, this is how I have declared my function, and then you have to call that particular function. So usually your function declaration, once you include all the header files, that is your whichever the according to your need. If you are calculating something, square root.h, stdio.h, conio.h, all this will include. After that part, you are going to declare your function. First, you need to declare what exactly is your function. What is the functionality of that particular nothing. So before writing any function declaration or maybe function definition, it is better to comment. You know how to comment in C, right? So a slash followed by a asterisk. After that, you will write something and then asterisk, and then you'll close with the slash. So that is my comment part. So that is the best practice what we do whenever we write the programs. So once you are done with the function declaration, then you need to write the definition of the function. So what exactly is the definition? Means a function would be returning, or maybe not, will not return any values. So all those different types of functions we'll see. So the function definition would be having a function header. So what header should be having, and then the function body. Inside the function body, you'll write all the complex statements or computational statements which you want to perform, that is the calculations. So that would be there in the function body. Function and header would be having all the different things, like what is the return type of the function, what is the function name, and then what exactly, how many parameters the function is taking. So as you can see in the slide, there is a prototype for a function, right? So it is telling type, what type, in the sense whether it is integer or maybe a float or a double or void. So there are different types, right? The same way here also function would be taking a type, and then f name. F name is nothing but a function name. So that is the function name, which is an identifier for your compiler when there is a function call has been done from the main function. So you need to give a proper name. Say for example, you are performing some division operation. You can just give a division as the name, or maybe add as a name, or maybe subtract as a name. So after that, followed by, you have so many parameters, right? As you can see, type P1, type P2, and then etc. So these parameters also should be given with the what kind of type they are. In the sense, a parameter P1 is a variable I call. So variable would be integer, float, double, that kind of thing. So you can give all those parameters. So, and the must and should is the semicolon for your function declaration. You should not miss the semicolon at the end of the function declaration, right? So that is the main key. Otherwise, you'll get some syntax error, right? So that is regarding the function declaration. Next, we will see an example of what exactly is function definition, how the function call happens. So I'm going to moving to the function call now. From this particular example, you can see, as I said, the program would start from hash include stdio.h, right? So that is the header file. Followed by, you have a function declaration. As you can see, the type is int, f name is add, and the parameters which I have given is int x, comma, int y, right? So those two are the parameters. As I said, type P1, type P2, the types here is integer type, that is x and y. As you can see, at the end of the function declaration, I have given semicolon. So always your function declaration should have a semicolon. Then I have written a simple function. I was able to do this, the addition of two numbers by writing result is equal to doing that. What I have done, I have, like module wise, like clearly I have written. So this is an addition function. If anybody sees this particular code, then they will get to know, okay, so he has written the, add function, or there is a function for addition. So which is taking two arguments. So in the third line, you can see int add followed by int a, comma, int b. So this is the function definition that we call it as function header. The function header, int add int a, comma, int b. So that is a function header. Inside the body, that is inside the parenthesis, you can see that it is returning a plus b, right? So that is my statement inside the function body. So what it is returning, a plus b. I have a return type called int. So both things, what I am doing the, at the next stage, or maybe at the next line, you can see avoid main. So as I said, your function or maybe the execution start from the main function. The first thing it would do is it is going to initialize that the result is in the form of integer, and then it is saying that result is equal to add 10 comma 20. It is passing two parameters to the function, right? So here after the result is equal to add 10 comma 20 is nothing but your function call. Whenever this particular function call happens, the control will go and point to the function definition which you have written, right? So the function definition would be int add int a comma int b. So to there the control will be written, and then you are going to get the value, that is 10 and 20 will be allocated to a and b. So here a and b are the formal parameters. Int a comma int b are the formal parameters. Int x comma int y are the actual parameters, right? Because that is my function declaration. So the actual things are x and y, but what I am doing, I am using some formal parameters, that is 10 comma 20. Once the calculation is done, that is 10 plus 20, it is going to return that value, that is 30, and then the things would be printing at the result. You are assigning the value 30 to the result, and then you are printing some is equal to result. So this is how the function call happens. So till now what we have seen the predefined functions or library functions we call them, and user defined function. User defined functions are nothing but where the user are by themselves are going to create, or we call them as PDFs also, that is programmers defined function. I hope this function call is clear for you people. Next, we'll move on to the categories of functions. What are all the different categories of functions that we have in the while writing the program, right? So let's start with first thing. So different categories: function with no parameters and no written values. There are some functions which do not take any parameters, and then they do not return any values. That kind of functions also we can write. The next is the function with no parameters and written values. A function with no parameters and a written value. There is no parameters which are passed, but there is some returning things which are which the particular function returns. Next, function with parameters and no written values. So for each of these different categories of function, we are going to see the examples, right? Function with parameters and no written values. And the next is function with parameters and written values. So to start with, function with no parameters and no written values. Now take this example. Hash include stdio.h, that is my first thing. After that what I have done void. I have used the void main. This void main would be okay. The void main is the function, that is the main function, which is actually what it is doing. It is calling the function, that is the void add function. There is a parenthesis which is missing here. You can just imagine there is a closed parenthesis in the add function. Add, that is the void add. So after this call, that is add happened, then the control will be moved from the main function to the calling function. That is, add is the calling function, that void add is the called function. So here you can see add is not taking any parameters, and then in the same parameters which are passed to that particular add. After that, you have something called as int a, b, c. Then you are using print, enter the values of a and b. You are using print f. So it should be a print f, enter the values of A and B, and then the scanf percentage D. So you are actually scanning the contents of A and B, comma ampersand A and ampersand B will be reading the contents, and then you are calculating, that is C is equal to A plus B. C is equal to A plus B. What it is doing, it is actually adding the contents, right? So the values of the numbers which you have taken from the input, that is A and B, will be added, that is C is equal to A plus B. Then you are printing again the things, that is followed by a bracket which is missing here. So you can just imagine a bracket which is there at the end of that particular function. So there is a function call which is happening from the void, and then the function, it is returning, right? So it is returning the printf statement. So that is the function return. So it is not returning anything over there. So function with no parameters and no return values. Next, we have function with parameters, and then it is going to return some values. So what exactly is that? Let's start with the program again. So first thing, it starts with the hash include stdio.h, where it is going to, that is the header file which we have include for standard input output operation, void add int a comma b. Int a comma b. So that is my two things which are actually the things as an input which I am giving. Then a void main which starts with the give me a minute. So we saw all these things. Next, we are seeing the parameters. So you can see here the scanf and the printfs kind of thing. So int a comma int b. So here we were like the functions with parameters and the return values. Int m comma n printf, you are actually asking the user to give the input, that is enter m and n. It is going to take the value. Printf, what it actually does, it will print enter m and n. The scanf is the statement which you are using in order to scan the values of m and n. Here the function with parameters and the return values, that is add m comma n, is the function call what you are doing. So once you do the function call over there, that is void add, it is taking two parameters. As you can see here, m and n are the actual parameters, a and b are the formal parameters. So the void add int a comma int b are the two things which is actually what it is doing. It is doing something like this. So void add int a comma b, it is telling that, so this is my function definition, which is with the function name, there is no return value, right? So usually what it is doing, there is a calling function and then the called function. The calling function here is the main, the called function is the void add, that is int c is equal to a plus b. So you are declaring a particular variable, that is int c is local variable to that particular function add. C is equal to a plus b is the value. After that you are doing a printf, that is sum is equal to percentage d. You are actually printing the c, and then again you are returning the values. Next, function with no parameters and return values. There is no parameters, but it is going to return some value. For that you can see there is we start with the hash include stdio.h and then int add. that is my function declaration with no parameters, right? So with no parameters, int add is my function declaration. After that, it is saying int c is equal to add. What I am doing here, I am assigning the value of whatever the calling function, that is my int add I am calling here. I am assigning the result to the c. So whenever there is a function which is actually called, int add is the function definition. So as you can see from the previous example, there was no return type, right? So it was not returning. From the previous example, it was printing there itself in the add function. Whenever you have written, it should have some type. That particular function should have some type. Here you can see int is the return type. So that is the return type of the function, where it is int a comma b comma c. I am reading three functions over there, sorry, three variables, that is a, b, c, of a and b. So after the getting that particular thing in the output, the scanf, you are telling that it is you are supposed to read the values, that is a and b, right? C is equal to a plus b is fine. I'm performing the addition operation, and what I am doing, I'm storing the contents into the C. Say for example, I have given some value as 11 and 12, right? So 11 and 12 is nothing but 23, right? So that 23 will be added to C, or maybe that value will be there in C, and you are returning that particular value to the C. So that is nothing but again, you are printing the same thing in the main function. You are not printing anything in the called function, right? So there is a calling function and then the called function. Here the calling function is main, and the another one is the called function is add. So that is the return function. Next, you can see once the called function, or maybe once the control is returned to the calling function, that is the main, you are going to print that particular value, that is 23. 11 plus 12 was 23. So that value will be there in the C, and you are going to print that in the C. Next, you have function with parameters and then the return values. What exactly with parameters and then the return value? So I have function which is having both arguments, the parameters. After that, it is having an int. You can see hash include stdio.h, that is int add int a comma int b. So that is my function declaration, void main, and then that is a for function declaration which I have done. Next, I should go to the main function, right? So my execution starts from the main function. So void main. After that, you are initializing the three variables, that is m, n, and c. So what exactly this m, n, and c, we'll see. Printf, you are asking to enter m and n. After that, you are reading the contents from the keyboard, right? So once you are reading the content from the keyboard, that is m and n, you are trying to perform the addition operation where you are calling the particular function add. So once the control comes to c is equal to add of m comma n, the control will move to this particular function definition, that is int add int a comma int b. So that is my function definition, which is having the parameters. And then I am, what I am doing, I am declaring or initializing one more variable, that is an integer type c. Then c is equal to a plus b. So whatever the value that you are going to pass as an actual argument, that is m comma n, that will be stored in the formal arguments, that is a and b. Say for example, you will read again 5 and then 6, that is m value is 5, n value is 6. Then it is going to take, a is going to take 5 and then b is going to take 6. So int c is the one which you have declared inside the function definition, right? So that particular variable, the scope of that variable is only inside that function, right? That is the add function. You can't take that C and A plus B and then you are going to return the C. So once it is going to return, so you need to look at the function definition. It is having type int and the function name add. So when you are returning the C, right, C is going to be written the value 5 plus 6, so that is 11, which will be stored in C, and the C will be not taking the value, so the 11 and then and the 11, that is the printf. Next it is going to print the value that is as 11. So this is nothing but function with parameters and then the return values. So once we are done with that, next we need to know which are all the ways that we can pass the parameters. So there are so many different ways of passing the parameters to the function. One is pass by value, the other one is pass by reference, and the next one is pass by address. So here in C you don't have something called as pass by reference, but here we have two types. One is pass by value and the other one is pass by reference. When it comes to pass by value, that is call by value, we see that it is also named as call by value, right? So the program goes something like this. So here is a simple program which actually what it does is it is exchanging the values of A and B to B and A, right? So here is a function which takes the arguments. So to start with the function, it include stdio.h, the header file. After that, I have written a function. So void exchange int m comma int n, right? So that is my function definition which I have written, and then in temp is equal to what I am doing here. I am initializing the temp. After initializing the temp here, I am assigning value of m to temp and then n to m, then temp to n. So temp is equal to m means, so whatever the value which is there in m will go and sit in temp. Whatever the value, or it will be assigned to temp. Next, whatever the value which is there in n will be assigned to m, and then whatever the value of n, that will be assigned with the temp value. So this is how we are going to exchange the value. Since we know that our program starts with the void main, that is the entry point of our particular function. So whenever a function enters over there, so int a comma b, so I am taking two variables over there, that is a comma b. I am telling that a is equal to 10 and b is equal to 20. What I am doing, I am calling the function that is exchange a comma b. So what I am doing, I am passing the values, so which are predefined, right? A is equal to 10, b is equal to 20 is the value, right? So that value I am passing with the actual parameters, that is a and b are my actual parameters. M and n which are there in the exchange is nothing but the formal parameter, right? So that's why I have written m and n are the formal parameters, a and b are my actual parameters. Once I pass these particular things, right, that is 10 and 20, 10 will go and sit in m and then 20 will go and sit in n. So initially the temp is null, right? Next, the temp would be having the value that is 10, and then once the 10 is assigned to temp means 10 will be not there in the m. So now you can assign the value that is 20 to m, and then again n would be empty now. Now what you are doing, you are assigning the value that is temp, that is 10 to the n. Now you got exchange, that is a and b got exchange, right? So that is nothing but pass by value. Next, pass by address. What exactly is the pass by address? So here we know that the variables which you are going to declare, right, or maybe you define, should go and sit in some particular memory location, right? So that memory location, we can use a pointer in order to locate that particular memory location, right? So here in this particular program, you can see exchange program or an exchange function is having parameters as pointers. That is, you can see int asterisk m, int asterisk n, right? So m asterisk followed by a particular variable m means you should get to know that it is a pointer, right? So whatever that we are doing, the exchanging of values is nothing but my and the passing the values. So integer is the temp is equal to star m. After that, next what you are doing, you are overlapping the things. Next you have void main function, you are calling the to function. How you are calling? See, you are using ampersand a and then ampersand b. Why ampersand a? Because I want to get to know the memory location. If I don't get to know the memory location, then I'll be not able to swap the contents, that is 10 and 20, right? So my execution starts from the main, that is void main. After that, I will read two variables, that is a and b. A is equal to 10 and then b is equal to 20. Then you are calling the function exchange. So whenever you call the exchange function, it is going to, the control will go to the void exchange, and then you'll start having this particular, values which are taken, that is 10 and 20. After that, you are going to get the values from the particular function, and then you are going to print what exactly is a and b. So this is why pass by address. So pointer, if you take the memory locations in the form of a stack, or maybe like you have a rows or thing which are given with the numbers. So if I want to go and access any address of a particular variable where it is sitting, then I will start use the pointers. So here is a simple example of a pointer, that is hash include stdio.h. What you are doing, you are writing a function which is a main, which is returning some value. There I am initializing the value of a. You can see there I am initializing a pointer, and then I am saying a is equal to 5, and you are assigning that particular value to the p. Now let's see after printing. So what happens? So the value of a is 5. Then you are using printf. You are trying to print what exactly is the, whenever I give ampersand a, what I will get. So I will get the location of a, right? The location of variable a, that is 1056. Say for example, in this fourth line, you can see p is equal to asterisk, that is ampersand a, sorry, not asterisk, ampersand a, which is assigned, that is 1056, right? You are assigning the value 1056 to the pointer also. So p, when you are trying to print the value of p, you are getting 1056. Then the printf, that is %d asterisk p, will give you the actual value which is present inside the variable a. The explanation, you can see value of a is 5. Address of a in the memory is different in the every one system. That depends on the system configuration. It differs from system to system. So p contains the address of a, and then star p contains actual the value of that particular address. So this is a pointer example. Next we have, so that is regarding the functions. So coming to the summary of this functions, what and all we have seen. So first thing we saw, what exactly is a function, right? So why do we need a function? So it is the modular approach. So that for that purpose, we are using these functions. We don't want to write 1,000 lines of code in a single block. What we need to do, we need to divide that particular 1,000 lines of code into a small chunks of code, that is nothing but my function. So I'll write them in the function. Then we saw what exactly is a library function, right? Like the predefined libraries, or maybe the header files, or the functions which are predefined. And there are some other functions which are called as user defined function. User defined function are the one which we are going to write. So when we saw the user defined function, we saw the function declaration. That is the prototype of the function declaration. And then the second thing was the declaration. Once the declaration is done, then we need to define that particular function. So function definition, which would be having the type and the function name and the number of arguments which are there in that particular function. Inside the function, we had so many different statements which are called as function body. Once the function body is done, then we were returning. So there were so many different types of function returns and all. So we saw all the 4 different types, that is the function with no return values and then no arguments, a function with parameters, there is no return value, function with no parameters, then return value, function with parameters, and then the function with return type. So all those four things we saw. So the 4 different things, right? So the next we saw what exactly is the function, how we can pass the values to the function. The function, you can pass the values using the address, or maybe the values, or maybe the reference. But pass by reference is not there in the C. Pass by value and then pass by address is there in the C. So for better understanding of this pass by value and the pass by address, you should know like what exactly is a pointer. So if you get to know in depth what is a pointer, then you'll easily understand all these things. And that would be my session for this day. Thank you everyone.